Hi everybody, it's Mrs. Walsh, and this is a video lesson on properties of rhombuses, rectangles, and squares. Make sure you take good notes. Alright, so rhombus, rectangles, and squares are all special types of parallelograms. They have all of the properties of parallelograms. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. All those things are still true, but they have some additional special features. So with a rhombus, the special additional thing is all four sides are congruent. With a rectangle, all four angles are right angles. So it's a parallelogram with all the qualities of a parallelogram, but with four right angles. And a square is interesting. It's a parallelogram that not only has four congruent sides, but also has four right angles. So that's what makes a square. So a square is really a parallelogram that's both a rhombus and a rectangle. That's what a square is. All right, so if we were looking at this picture and we were looking at parallelogram, we're being told it's a parallelogram, A, B, C, D, and we're trying to classify it as which type of special parallelogram. Well, I can see this is a right angle, and I know in parallelograms that opposite angles are congruent, so this must be right as well. And I also know since these two sides are parallel, since it's a parallelogram, the consecutive or same side interior angles are supplementary, so that would make both of these right angles too. So now that I have four right angles, I know it's a rectangle. Okay, additionally, they want us to look at E, F, G, H, and we're being told it's a parallelogram. Well, we're also being told these two sides are congruent. But I know opposite sides are congruent in a parallelogram, and now I know that all four sides are congruent, but I know nothing about angles, so I can conclude that this is a rhombus. All right, and let's talk a little bit more about some properties that involve diagonals with these special parallelograms. If a parallelogram is a rhombus, then I know its diagonals are perpendicular to each other. So if I have diagonals, they are perpendicular. All right, now, if I know a parallelogram is a rhombus, I also know that the diagonals bisect a pair of opposite angles. So here and here, here and here, they're bisected. So knowing that information, if I'm then asked to find the angle measures in this drawing, well, I know that the diagonals bisect opposite angles in a rhombus because they're telling me that this is a rhombus. So that means this must be 58 degrees. And since I know that these two angles are congruent in a parallelogram, number 2, measure of angle 2, must also be 58 degrees, as must the measure of angle 3, since they are bisected, be 58 degrees. All right, well, I also know that in a parallelogram that the diagonals are perpendicular, so that means the measure of angle 1 has to be 90 degrees. And once I know that 1 is 90 and 3 is 58, I can calculate 4 because this is a triangle, right? So those must add up to 180. So 58 and 90, then I know the measure of angle 4 must be 22 degrees. I'm sorry, 32 degrees, because that will get me to 180. All right. All right, what about in this case? Well, I know this angle's 104. I know these angles bisect each other and are congruent, right? So all of these are congruent. So I know that these two are the same, and that's 104, and they all must add up to 180. So that means the measure of angle 1 plus the measure of angle 3 has to be 76 degrees. But since I know they're congruent to each other, I just divide 76 in half, and I get the measure of angle 1 is equal to the measure of angle 3, which is really equal to the measure of angle 2, which is really equal to the measure of angle 4, and all of them are equal to half of 76, which is 38 degrees. All right, let's look at some rectangle properties. We learned what diagonals in a rhombus do. What do diagonals in a rectangle do? And diagonals in a rectangle are always congruent. All right, so where a rhombus, they're perpendicular and they bisect opposite angles. In a rectangle, they're congruent. And these are things you're going to have to know. You're going to have to memorize. So if I was given this diagram and told that SF was 2x plus 15, and that RB was 5x minus 12, and I wanted to find the length, what will I do? Well, we already know from the last slide and theorem that these diagonals are congruent to each other because we're being told it's a rectangle. So that means that 2x plus 15 must be equal to 5x minus 12. And that means that 3x is equal to 27, and x would be equal to 9. But that's not what they asked. They want the length of the diagonal. So it should work plugging into both of them. So in the top case with SF, that would be 18 plus 15, which is 33. And if I was looking at RB, that would be 45 minus 12, which is equal to 33. So the length of the diagonal is 33. All right, now we're going to kind of look at what they call conditions, but I kind of just think of it as a converse of what we've already learned. If what we know, if all we're given is a diagram that shows that I have a parallelogram and the diagonals are perpendicular, I can 100% conclude that that parallelogram is a rhombus. Additionally, if I've been given a diagram and it's a parallelogram and I know one diagonal, just one, bisects a pair of opposite angles, then I also know for sure that this is a rhombus. So once again, it's kind of the converse of what we just learned about the properties. And then in terms of rectangles, if I'm given a parallelogram and I know the diagonals are congruent, I can 100% conclude that this parallelogram is a rectangle. All right, so I kind of like these. We're given special diagrams here, and we have to see how we can classify these parallelograms as specifically as possible. Well, this one relates directly to what we just discussed. If one diagonal bisects a pair of opposite angles, then we know it's a rhombus. And here, we find a number of things. First of all, we see this right angle symbol. That means the diagonals are perpendicular. That means it's a rhombus. But this is congruent to this, which is congruent to this, which is congruent to this. This means that this diagonal length and this diagonal length are congruent. And it's rectangles that have congruent diagonals. So now I'm kind of stumped. I have conditions for a rhombus. I have conditions for a rectangle. And remember what we discussed. A square is a special parallelogram that is both a rhombus and a rectangle. So the proper classification of this parallelogram is square. Now here, I'm being told, and you probably can't read this, but I'm being told that SO is congruent to TP. Once I know the diagonals are congruent, I know in fact that the parallelogram is a rectangle. And in this one, all I know is that the diagonals of this parallelogram are perpendicular to each other, but that's all I need to know to label this a rhombus. Okay, so let's do your favorite, and let's do a proof. All right. I'm given that this figure here is a parallelogram, given that ABCD is a parallelogram, and I need to prove that AO, this segment, is congruent to OC, this segment. So when I look at this, I, of course, never just start a proof without having a game plan. So my game plan here is going to be that I want to prove, I feel like, if I can somehow prove that this triangle and this triangle are congruent, then through CPCTC I can get these two sides congruent. That might be a way I can do it. Now, the other thing I can do that would be very quick is I do know that in every sort of parallelogram that the diagonals bisect each other, but I'm going to pretend that I don't have that, because I just want you guys to practice using some more properties of parallelograms, because I could just go straight to saying, well, AO is congruent to OC because diagonals bisect each other in parallelograms. But let's make it a little more fun than that. Okay, so I'm going to start the way I always do with my statements and my reasons. Whoa, I spelled that wrong. Statements and reasons. Okay, so the first one is A, B, C, D is a parallelogram. And my reason is it's given. Okay, next. I know in parallelograms that their opposite sides by definition are parallel. That's why it's called a parallelogram. So I know AD is parallel to BC, and I know that AB is parallel to DC, and that's the definition of a parallelogram. Okay, great. Next. I'm looking at this, and let's just start with the AD and BC part. I can see that if I do this, I have two parallel lines cut by a transversal, and that would make this angle and this angle congruent because of the alternate interior angles theorem. So I'm going to state that because I'm trying, once again, remember, to get these two triangles congruent. So I'm going to say that angle DA, and I could have said O, but I'll say C, is congruent to angle BCA, and the reason is alternate interior angles theorem, because I already proved those lines to be parallel. And I can also then, if you look at these two parallel lines with this transversal, I can do this angle and that angle, and that's really helping me out on my road to getting those triangles congruent. So I'm now going to say that angle ADB is congruent to angle CBD, and that is because alternate interior angles theorem. All right, so now I got two angles. What else do I know about parallelograms? Well, I know that in parallelograms, opposite sides are congruent. Now, that's not the definition of a parallelogram. That's one of those 6-point whatever theorems we learned, that opposite sides in a parallelogram are congruent. So I'm going to say that AD is congruent to BC. And my reason, you know I don't like quoting numbers of theorems. It's because alternate sides, or opposite sides, say opposite sides of a parallelogram are congruent. And that's just the truth. Opposite sides of a parallelogram are congruent, which was a theorem. And so now that I've got these sides congruent, these angles congruent, these angles congruent, guess what I have? I have triangle ADO is congruent to triangle CBO. And the reason is angle, side, angle congruence theorem. Okay, great. So now that I have them congruent, I have reached my final goal. And I can say that AO is congruent to OC, and I can say that by CPCTC. Okay, so sorry for a little bit of my messiness there. Hopefully that made sense.